This is the first video for chapter 6 in your book. It's all about chemical reactions. So we're starting to get into some real chemistry here. And not only are we going to look at just kind of observations of types of chemical reactions, we're also going to be doing a lot of calculations with them. So for those of you who have been kind of skating along in this class, the math has been easy, the concepts have been fairly easy for you. Chapter 6 is usually where the intensity gets bumped up. And it will be, basically the intensity will be bumped up for all of you in this class. If you have been working really hard, hopefully the study habits that you've been developing for this class will pay off once you get into this chapter. This chapter, I would say, takes the most amount of effort and time for students. The concepts, especially if you are not a math-brained person, can be difficult, but hopefully I'll be able to break them down for you so you can think about them in a non-mathematical way to try and help apply the mathematics that we're going to be doing. Okay. So the first section basically is kind of an intro to our chemical reactions, and we're going to talk about balancing chemical equations. Oops. So first off, what we kind of want to make sure we understand is really what is chemistry? What is it that we're doing in this class? Now it's a little odd sometimes to define chemistry once we get, we're halfway through the quarter, but really we haven't gotten too much in depth into chemistry until now. Okay, once we start doing chemical reactions, that's really what we're interested in as chemists. So chemistry is defined as the study of matter, which we talked about in chapter 2 is where we first introduced that. But really what the interesting part of chemistry is, where people consider is chemistry, is where we study the changes that this matter undergoes. And we have already talked about our two different types of changes. We talked about our physical changes versus our chemical changes. So our physical changes, just to kind of remind ourselves of what we're dealing with, is we have a change in appearance. And sometimes the delta symbol is symbolized for change. We've seen that symbol in when we talked about specific heat. So what we're talking about when we're changing in appearance, kind of basically your physical descriptors. So we have color, what the state is, the shape, okay, things like that. Our chemical changes, this is where we're changing the identity of our substance or the chemical. The important thing to note for our physical changes is this does not change the identity. Okay? Whatever chemical we start with, we end up with. That's very important because when we look at our chemical changes, now we're starting with one chemical. We're going to rearrange the atoms and put them back together differently so that we have a new or different chemical. Okay. So basically, you're going to put it back together and you're going to have a new chemical. The way that we represent chemical changes, okay, is we have chemical equations. So far, we've seen some equations, but we refer to those as mathematical equations. Now we're looking at chemical equations. And I kind of think of these almost as really basic, simple recipes for the reaction. By the way, shorthand for reaction, I use RXN. We're going to use that word a lot, so you'll probably see that. The basic components of our chemical equation is we're going to start with our reactants on the left-hand side. Then we'll have an arrow that will point to our products. And we just call this guy here, this is our reaction arrow. Some things that are included, not always, but they can be, we can include our phase or state. So you could have your solid, liquid, or gas, and we put those as lowercase letters in parentheses. And we'll see some examples here in a moment. We have a fourth phase or state, and this is called aqueous. So AQ means aqueous. And what it means is whatever component is aqueous, that means it's in water. So when you made your salt solution for the chromatography lab, or the second part when you did the solutions lab, you made a sodium chloride aqueous solution. So we would actually write that as NaCl, and then to the right of that AQ. So that the sodium chloride was in the water. It wasn't liquid. You didn't melt it. You didn't change the state from a solid to a liquid. You actually took that liquid and dissolved it into the water. And so that's what we mean by aqueous. So our phase, our state, these symbols here, these are listed after the chemical formula. And they're not a subscript or superscript, they're just put in as regular text. Sometimes we can include some other information about the reaction. For example, if a reaction requires heat, and we may see this kind of throughout the quarter. But we have a number of different ways that we can do that. We can say over the reaction arrow, put a delta symbol, so the triangle representing that heat had to be added. Other times you'll just simply see heat over the reaction arrow. Or we could just say plus energy in the reaction itself. And actually at the end of chapter 6, in the very last section, we'll talk about reactions that either give off heat or absorb heat. So we'll see this again. So that's kind of the things that we can add to a chemical equation. Another important component to our chemical equations that we're going to be using throughout this chapter is that we always want to be using balanced chemical equations. So our key word here being balanced. Basically what this means is that we obey our law of conservation of mass, and that's where whatever atoms we start with, we have to end up with. We can't introduce new ones just from because we feel like it. Whatever we start with, we have to end up with. We also can't have extra atoms. Okay, so think of it kind of as you're putting together a puzzle. If you start with all the puzzle pieces, you can't say that your puzzle isn't finished until you have all the puzzle pieces back in place. Can't have a spare one lying out. You can't have just a missing hole of a missing piece of the puzzle. You have to have whatever you start with, you have to end up with. How we represent these balanced chemical equations, okay, how we represent the balanced portion. We use coefficients. And these are going to be the numbers that are out in front of the chemical formula. So when we change the subscripts in our formulas, remember those are the numbers that go lower, those we can't change once we've established that that's the chemical that we've formed. If we change the subscripts, we're changing the chemical. Okay, so once we've established what chemical we're either starting with or ending with, we can't change those subscripts. To balance out our equations, we're going to put these coefficients to say that rather than just having, say, one molecule of water, we have 2 molecules of water, okay, in order to get all of our atoms to balance. So it's very, very important that we cannot ever change the subscripts to balance the chemical equation. Now, that's not to say that we can't change the subscripts. Okay, when we're doing a chemical equation, the whole goal is to change the subscripts so that we can change our substance. Okay, so from the left-hand side versus the right-hand side, the subscripts can change and most often do. But once we've established what chemicals we've started with and what chemicals we've ended with, we can't change those subscripts. Okay, those are what they are, because if we change the subscripts, we're not talking about the same chemical. So once we've established what our reactants are and what our products are to balance our chemical equation, that's where we use our coefficients. Okay? So let's look at a simple example. Let's look at, say, the formation of water. So we're going to take H2, that's hydrogen. Remember, it's diatomic, so it gets its element name. So we have hydrogen in the gas phase, and we're going to combine that with oxygen in the gas phase. And we're going to form water. Let's make it interesting. Let's say we're going to condense it. We're going to have it in the liquid phase. So this is a basic chemical equation. It's showing that we're starting, our reactants that we're starting with are hydrogen and oxygen. And we're going to combine those together to form water. Okay. Now, as it stands right now, this is an unbalanced equation. Okay. So in black, so this is unbalanced. Okay. Also, shorthand for equation, EQ, I put my N as a superscript and I underlined it. Some people just do EQ apostrophe N, okay, for equation. Use whatever works for you, okay, whatever you would like to use in your notes. So right now this is unbalanced, okay, and the reason for that is although we start with 2 hydrogen atoms and we end up with 2 hydrogen atoms, we start with 2 oxygen atoms and only end up with 1. Okay, so we have to somehow get another oxygen over here to make sure that we balance out those oxygen atoms that we started with. Okay, now it's really tempting to go, all right, well, if we just have H2, and I'm going to leave off the phases because they don't mean anything to us right now while we're balancing. So it's really tempting to go, all right, well, I started with 2 here, started with 2 here. Let's just change that subscript and say, hey, if I just add a 2 right here, my life is very simple. Now we're balanced. Okay. Problem is remember I said we were looking at the combination of hydrogen and oxygen to form water. When we add a 2 to this subscript here, we've now changed this compound. This compound is no longer water. Okay? And it's, in this case, for humans, it's a very important distinction that we understand that these are 2 different chemical compounds. Okay? Water, good for you to drink. Arguably, you're supposed to drink, what, like 8-ounce cups a day? Okay? Here, this is hydrogen peroxide. Okay? You're not going to make it too long if you're drinking 8-ounce cups of hydrogen peroxide a day. Okay? Hydrogen peroxide is a poison to humans. So by adding that subscript, yes, you balanced out your equation, but you changed the chemistry that was happening. Okay? So we can't do that to balance the equation out. Instead, we want to look at adding our coefficients. So instead, we're going to, again, stay with the equation that we've established. Okay. We have hydrogen plus oxygen to form water. We already knew that we had a problem here and we had 2 oxygen atoms and only 1 oxygen atom in our product. So what we can do is, remember, we can add coefficients. So if we start off with 2 oxygen atoms and we need to end up with 2 oxygen atoms, we can stick a 2 out in front. Okay? And what this means now is we're going to form 2 molecules of water. And that will give us our 2 oxygens. But now our problem is we have a total of 4 hydrogen atoms. Okay, we have 2 water molecules. Each water molecule has 2 hydrogens. So we have a total of 4 hydrogens in our products. But as it stands right now, we only started with 2 hydrogen atoms in our reactants. So to balance that out, we put a 2 out in front. Now we have 4 total hydrogen atoms, 2 oxygen atoms. We're going to end up with 4 hydrogen atoms and 2 oxygen atoms. Now, this is a balanced chemical equation. And that's what we're looking to use when we're doing any sort of calculations, as we're going to be doing in the remainder of this chapter. So, what I'd like to do now is give you some guidelines for how to balance more complicated reactions than this, because it can be kind of a back and forth type deal if you don't have a method to your madness. So let's look at how to balance chemical equations. There are a number of, don't know how I got so far over there. There are a number of different ways to go about balancing chemical equations. Okay, and it's not that one way is wrong, it's not that one way is right. Just some ways I find students have an easier time than others. Okay, I find the way that your book goes through it a little confusing. It wasn't the way that I was taught. It isn't the way that my mind works. So what I'm going to do here is give you my kind of rules for how I balance chemical equations. It's also going to match the rules in the way that Khan Academy shows how to balance chemical equations. So I encourage you to maybe start with my method and the Khan Academy method. Again, those are the same general approaches. And try a bunch of equations out. Okay, give it its fair shot. If you're still not getting it, then start from scratch and try reading your book. Okay, the important thing is that you don't want to combine my method and your book's method. If you combine the methods, you're going to go in this downward spiral and, head into La La Land with, the rabbit hole and whatnot. So, choose a method that works for you, but don't combine methods. So the first step to any method in general is that you need to write out your correct formulas for your reactants and your products. Now, a lot of times this step is going to be done for you, so just keep that in mind. Don't take it for granted. Okay? But sometimes you might be given some examples, perhaps maybe on a homework assignment. But you might get some examples that are in words, okay, telling you, describing what's happening with the chemical equation. So you're going to want to make sure that you remember and follow all of your rules from chapter 5. Okay, naming is not going to go away. Remember, I said at the beginning of this quarter, chemistry is a very cumulative subject. So each quarter or each chapter is going to be building on the previous one. Okay, especially starting from chapter 3. Chapter 3, you learned about atoms and elements. In chapter 5, you put those atoms and elements together to form compounds. In chapter 6, now we're going to start combining compounds to form new ones. And then in chapters 7, 8, 9, and 10, we're just going to be talking about those new different types of reactions that we can have. Okay, so it's important that you master each chapter before you move on. So once we write out our chemical formulas for our reactants and our products, okay, I suggest that you start with the most complex compound, basically the scariest, okay, whichever one looks the most terrifying to you, and assign it a coefficient of 1. Basically what you're doing is you're trying to add simplicity to how you're going to balance your equations. Okay? Then once you have that coefficient assigned, that is the only coefficient that you're ever going to just blindly assign. Okay? Otherwise, the rest of your coefficients have to come from some other piece of knowledge in that balanced chemical equation. Okay? So the next steps basically are going to add your coefficients to the rest of your chemical formulas, balancing each atom in this starting compound. Then basically you're going to assign any remainder coefficients. Okay, look at what hasn't been given a coefficient and determine what its coefficient should be. Then I always say that you should do a final check. For your balanced chemical equation. And that's just to make sure that you didn't do any silly mistakes or you didn't reassign a coefficient and didn't realize that you had already assigned it, something like that. Okay. Then also kind of a final check with this is you want to reduce all of your coefficients to the lowest multiple. Usually what that's going to mean is if all of your coefficients are evens, you can divide them all by 2 to get them reduced down. Okay. On a rare occasion, you might see as high as they're all multiples of 3, divide by 3 to get to the lowest one. The most common I see is if all of the coefficients are even, you just have to divide by 2. So let's work through a couple examples. And you're going to want to work through lots and lots and lots of examples. Okay, your goal at the end of all of this practice, not this video, you probably need a little bit extra, but you're going to want to be able to balance a chemical equation in less than 60 seconds. Okay, you want to get it so that it's second nature to you. So let's work out some examples. So let's look at AgCl. Okay. Also, it's a good practice to name all of the compounds that you are working with. So this is silver chloride. I would also accept silver 1 chloride. Silver was one of the exceptions to the transition metals, but I don't require you guys to know that. So silver chloride or silver 1 chloride would be okay. And then we have MgO, magnesium oxide. And we're going to do a reaction with those to form silver oxide and magnesium chloride. When I'm balancing my chemical equations, I usually put a little line out in front, give myself some space, and it'll really show me if I'm assigning my coefficients. Now, coefficients of 1 can be left off. I suggest not leaving them off and actually putting them in. That way you know that you've actually assigned a coefficient and it's not remaining to be assigned. Okay. So it doesn't matter where you start. Okay, this isn't a very complex example. So the most complex compound or the scariest compound is going to vary from person to person, and it really doesn't matter where you start. Okay, I'm going to choose to start with silver oxide. I don't know, that 2 by the silver just kind of freaks me out. No reason why. Okay, so what we want to do now is we want to add coefficients to balance each atom in our starting compound. So I'm going to balance the silvers. I have 1 silver oxide, and I have 2 silvers per silver oxide. So I have 2 silvers. Where I find silver in my reactants is in silver chloride. I only have 1 of those per molecule. Okay, and I had to end up with 2, so I need to start with 2. So I need a coefficient out in front of 2. And then I go back to my starting compound, go to my next element, which is oxygen. I only have 1 oxygen, so I go to my reactants where I find oxygen here and magnesium oxide. I get 1 of those per molecule, so I just need a 1 in front of magnesium oxide. Going back to my starting compound, I don't have any elements left to balance. So now I want to assign any remaining coefficients that haven't been assigned yet. Okay, the only one that hasn't been assigned is for magnesium chloride. And we can either balance the magnesium or we can balance the chlorine. Okay, it doesn't matter. So we want to look somewhere in our equation to see how many magnesiums we should end up with. Okay, so our magnesium is over here. We have 1 of them. So over here in our products, we're going to need a 1 out in front of the magnesium so that that is balanced. Okay. So I've assigned all of my remaining coefficients. Now I want to do a final check for my balanced chemical equation. And how I do that is I list my elements. Then, it's really hard, but you want to not cheat and you want to look at one side at a time. Okay, so I want to look at my left-hand side, see how many atoms of each of these elements I have. So I have 2 silvers. I'm not left-handed, so I'll write this down in a second. So I have 2 silvers. I have 2 chlorines. Okay, that 2 out in front gets distributed to both atoms. So 2 silvers, 2 chlorines, 1 magnesium, and 1 oxygen. Okay, so I write those numbers on the left-hand side. So I have 2 silvers, 2 chlorines, 1 magnesium, and 1 oxygen. Now I do the same thing, covering up the left-hand side now. No cheating. Okay. And the reason why I say no cheating is because if you made a mistake, if you cheat during this step, you're most likely to make the same mistake. Okay, so if you don't have self-control, really do cover it up with your hand. So I have 2 silvers, I have 1 oxygen, 1 magnesium, and 2 chlorines. Now I just go and make sure that I have the same numbers on each side. So I have 2 silvers that I start with, 2 silvers that I end up with. 2 chlorines that I start with, 2 chlorines that I end up with. 1 magnesium I start with, 1 magnesium I end up with. 1 oxygen I start with, 1 oxygen that I end up with. Okay. So this is a balanced chemical equation. Usually I've just gotten the habit of putting a check mark when I know that they're balanced. All right, let me put up a couple more examples. Okay. And you guys can write them down, pause the video, and try to balance them yourselves, and then I'll balance them for you afterwards. So again, go ahead and pause the video, try these out on your own, okay, and then unpause, and I will show you my solutions. All right, so we have hydrogen bromide combining with aluminum hydroxide, and we're going to form aluminum bromide and water, okay, or dihydrogen monoxide. It's a chemical name. Aluminum hydroxide, definitely the most scary here. It has some parentheses, so I'm definitely going to start by assigning this a 1. So I start by balancing each element, okay, in my starting compound. So I have 1 aluminum, so I go over to my products, and I need 1 aluminum. I go back, and I have 3 oxygens for each molecule of aluminum hydroxide. Okay, I have 1 aluminum, and remember this 3 around the outside means that I have 3 hydroxides. That's a polyatomic ion. So I have 3 of those, which means I have 3 oxygens and 3 hydrogens. Okay. So 3 oxygens, what I get from my aluminum hydroxide. So I need 3 oxygens accounted for in my water. So I need a 3 out in front there. Now one tricky thing is if we went back to our original compound, we have hydrogen here, but you want to be aware that we also have hydrogen coming from our hydrogen bromide. Okay, so our hydrogen is coming from 2 spots, so we can't balance our hydrogen, okay, we can't add any coefficients, we're using just this compound. So in order to get this coefficient here, okay, we can either balance our hydrogen or we can balance our bromine. Hopefully you can see how to balance the bromine. I'm going to show you the hydrogen, okay, because it's a little more complicated. So over on the right-hand side, our product side, okay, we have 6 hydrogen from our water. In our reactants, remember we're getting hydrogen from 2 different places. We're going to get 3 of those hydrogens come from our aluminum hydroxide. Okay. So the remaining 3, in order to get a total of 6, has to come from hydrogen bromide. So we have a 3 out in front. We'll do our final check. I have 3 hydrogen from HBr plus 3 hydrogen from my aluminum hydroxide for a total of 6 hydrogen. I have 3 bromines from my HBr. I have 1 aluminum from my aluminum hydroxide and 3 oxygens from my aluminum hydroxide. Then I am producing 1 aluminum from aluminum bromide, 3 bromines from aluminum bromide. I have 6 hydrogen from my water and 3 oxygens from my water. So I have 6 and 6, 3 and 3, 1 and 1, and 3 and 3. So that is balanced. Last example here. Again, I would choose calcium hydroxide here. It definitely looks the scariest. So I'll stick a 1 out in front. I have 1 calcium, so I need a 1 out in front of my calcium. I have 2 oxygens. Okay, remember that 2 gets distributed to both the oxygen and the hydrogen. And I only have 1 calcium hydroxide, so 2 oxygens, meaning I have a 2 out in front of my water. This is another example where hydrogen is split into 2 different atoms or 2 different compounds here. So in order to get this coefficient, I look to see, and I have 4 hydrogens that I'm starting with. 2 hydrogens have been accounted for in calcium hydroxide. So I need 2 more accounted for here, which means I need a 1 for my coefficient. Now I have calcium, hydrogen, and oxygen. I have 1 calcium in my reactants, 4 hydrogens in my reactants, and 2 oxygens in my reactants. In my products, I have 1 calcium, I have 2 oxygen, and I have 2 hydrogen from calcium hydroxide, and 2 hydrogens from hydrogen, our molecule of hydrogen, for a total of 4. So I have 1 and 1, 4 and 4, 2 and 2. So that is a balanced chemical equation. So like I said at the start of this video, you're going to want to practice balancing chemical equations. Get your method, whatever method works for you. Okay, try my way and watch also the Khan Academy. He goes through another set of examples. Okay, work through as many examples as you can. Find equations in your book that have already been balanced. Recopy them without their coefficients. Try and balance them, and then you can check your book because you took it from a balanced chemical equation. Okay. So you really want to get these balancing down to taking less than 60 seconds to balance a chemical equation. If you can't balance a chemical equation in less than that time, it's going to take you too long to do the exam. Okay, so practice.